Welcome to United Astronomy Clubs of New Jersey. We are here for the last presentation of the season where we're going to be here in Jenny Jump State Park in Hope, New Jersey. And because it is the last weekend in October that's close to Halloween, we get to be a little bit spooky. So anyone who came in costume, yay. That being said, I don't know if we had a couple people still wandering down from the parking area, and I want to give them a chance to wander down and find themselves a patch of ground to occupy. But I do want to welcome everyone here and online because that is right. We do live stream these to both YouTube and Twitch. So if you're ever looking for something to do on a Saturday night, do join us online because all throughout the winter we are going to be still live streaming over there, though we won't be here. In addition, I want to encourage everyone to look us up on our website. It has a whole bunch of useful information like our upcoming talks, as well as information on our member clubs because we are a club made up of other clubs. And one of the easiest ways to get into astronomy is to actually join your local club, if not for just ease of travel, but also because they're going to have all the tips and tricks and cool, neat hidey holes where you can get the best views. For example, we have clubs out in New York City, and they're going to be great at telling you where and what you could find out there. That I, out here in Warren County, New Jersey, will definitely not know because I'm used to dealing with a bit less light pollution. In addition, you can always follow us on our social media pages, our Facebook, Instagram. We have a Discord server, all great places to get in touch with us, ask questions, or even just share your astrophotography photos or pics of your the latest astronomy or space meme. Someone had posted one that was funny earlier in the week. With that, it is time for the safety briefing. If anyone here needs to use the restroom, that is the porta potty in back. It is big, it is blue, it is illuminated by red for ease of finding in the dark. We also have a little museum and gift shop area, which I have some I believe my sister's in there manning it. I don't know. There might be someone else manning it, so they might have switched out on me. That being said, feel free to check that out. All proceeds go to keeping the bills paid and allows us to continue the free public outreach that we do here. Each of those sheds you saw coming in houses its own telescope. If we get a break in the clouds, we might open one up, but I don't know how well they'll be. I'm going to see if I can get a couple of our volunteers to at least open a couple up so you can go see at least the telescope setups that we have in there later after the presentation. Speaking of after the presentation, it is going to be dark since we are in a state park and it is cloudy. So we do encourage people. We want you to use your headlights when you leave because we do not want to actually get run over. Last night of the year, let's keep the 0 people run over in a night theme going. That being said, if we are using any flashlights or whatnot to walk around, I do ask you keep those lights pointed towards the ground when you can, just so we don't accidentally blind people, because the latest, greatest 10,000 lumen monstrosity from Amazon is no fun in your retinas. Don't ask me how I know. That being said, you're not here to listen to me blabber on for forever. You're here to listen to Dan. Dan Kirby has a bachelor's degree in physics with a minor in history and a master's degree in computer science. He has been an amateur astronomer since childhood and is a member of the board of Amateur Astronomers Association of New York. And he's also on the board of the United Astronomy Clubs of New Jersey, which is us. He's the site coordinator for AAA's activities here and has spent many a lonely night, which is a lie. He has friends. They all do astrophotography, get together, do astrophotography. He is not lonely when he's here at Jenny Jump. Uh, and while astronomy by far is Dan's most passionate hobby, he also enjoys reading, both fiction and nonfiction, cycling, camping, and writing self-balancing personal electric vehicles. And for his day job, Dan's a software engineer, and you can follow him on his Instagram, which he'll probably shamelessly plug later. With that, here's Dan.
I'll have you know there is no shameless plug of my Instagram in this talk. Yeah, so this.
So fix that.
Whoa, hello. What? Okay. Yeah, so the title of this talk is How, Where, When, and Why to See Cool Space Stuff. And so if you've seen my other talks, which I'm sure you're all avid fans of me, this talk is kind of the third in a series I've been doing on introductory amateur astronomy. So it's kind of a companion. So the other two talks are called So You Want to Buy a Telescope and Everything You Ever Wanted to Know About Astronomy But Were Too Afraid to Ask. So You Want to Buy a Telescope is very equipment oriented. It's kind of aimed at like, all right, you're sure that you want to get into astronomy, you want to buy your first telescope. This is, the roadmap of what is available in the market. I'm gonna have to rewrite a lot of that talk because Orion, one of the biggest telescope manufacturers, just went out of business. Everything you ever wanted to know about astronomy but were too afraid to ask is kind of an intro astronomy, like the stuff you would get in an academic astronomy course, but condensed down to the length of a 45-minute talk. So both of these talks are kind of intended to help people get into the hobby. This talk is kind of about the bucket list items, the things that you might want to experience even if you don't really want to buy a telescope or don't want to get into astronomy, or that maybe if you are in the hobby, you might want to do just once, just to cross it off the list and see whether you want to have that experience. So we're going to talk first about constellations in the Milky Way. We're going to talk about the moon and the planets. We're going to talk about eclipses and transits. We're going to talk about galaxies, nebulas, and star clusters. We're going to talk about comets. We're going to talk about auroras, meteor showers, and satellites. So you will see I have grouped these kind of based on things that are similar in the sense of like how easy they are to see or how ephemeral they are, or things that are similar to one another. But first, I always want to make a note about light pollution. Over 80% of the world's population is affected by light pollution, and astronomers use what we call the Bortle scale to classify the quality of the night sky. So this is a scale from 1 to 8. Sometimes I've seen it go to 9, specifically for places like New York City. Where we are here at Jenny Jump Observatory is a 4.7, probably going to be a 5 pretty soon. Cherry Springs is a pretty famous location in Pennsylvania, Potter County, Pennsylvania, where that has an astronomy park. It's a Bortle 2. If you want to get a Bortle 1, which would be a natural dark sky, like what the sky was like before human beings started polluting it, then the only one that you can find on the East Coast is in the Katahdin Wilderness of Maine. Many of the objects we're going to talk about tonight require a night sky that is better than a Bortle 6, but not all of them do. And you will notice at the bottom I have helpfully included a little thing that tells you whether you need a dark sky to see this object, and also whether you need a telescope to see this particular object. But yeah, light pollution is really bad. It's getting worse at an alarming rate, and it is a choice. We do not need to do this. All of the light that we shine up into the sky is wasted energy. We don't get anything for doing it. And you can help prevent light pollution by making responsible lighting choices for your home or business. If you're interested in that, you should get involved with the International Dark Sky Association, which I'm a member of. Their website is darksky.org. So first we're going to talk about the constellations. So you can basically see constellations from anywhere, though they will become less interesting in the city. An interesting thing about the constellations is that you kind of actually they actually kind of peak in, I would say, like Bortle 4, like 3 and 4. Once you get to really, really dark skies, it's actually kind of harder to pick out the constellations because there's so many background stars that the bright stars that make up the constellations are not as obvious. But they are made up. We human beings made them up, and you can even make up your own. People do that all the time. Made up constellations that are not part of like the Western canon of constellations are called asterisms. And there's a really famous asterism in the middle of this map here. You see this triangle? That's called the Summer Triangle. So that triangle is made of, here, I'll use the cursor so you can see this here. So this is made up of 3 bright stars and 3 constellations in the Milky Way. Particularly notable is Cygnus, which is a cross. You're going to see Cygnus pop up again. So if you want to look identify the constellations, get to know the star lore, I recommend getting an app like Stellarium, which is the one I use. There's also one called Sky Safari. There's a bunch of other mobile apps you can get for this. You can also get paper maps, or you can get a planisphere, which is what this thing is. So planisphere, the way it works is you see it has the months of the year around the outside. It has the time of night. So you can basically you spin it around to what the current conditions are, and then you'll see that it has it north, east, west, and south. Now that looks a little weird, right? Because you're used to it's never eat soggy waffles, but because you're looking up, the west and east flip because you're looking the other way. So yeah, with this you can this is a really nice way to see what the sky looks like without looking at your phone and screwing up your night vision. So do you need a telescope to see the constellations? No, and actually it would probably be a hindrance because once you zoom in on them, you're just looking at a little tiny piece. And do you need a dark sky? Probably not. Though it is harder to see them in a big city. So now about the Milky Way. So the Milky Way is your home galaxy. You live inside the Milky Way. You can see the Milky Way all year round because it is this ring that goes around us. But during the summer, it's a lot brighter and more impressive because the side of the Milky Way that we are seeing in the summertime is toward the galactic core. So you see in this picture here, you see that this is the constellation Cygnus. So if you ever want to find the Milky Way in the summertime, you want to look for this cross. Cygnus, the swan, is flying straight through the Milky Way. So this is a picture I took of the Milky Way from Cherry Springs Star Party this summer. So this is looking south. This is looking straight towards that galactic core in Sagittarius, which is on the southern horizon in the summertime. You probably need at least a Bortle 5, maybe a 4 to really see the Milky Way. Certainly the winter Milky Way, you probably want to be better than a 4. You can photograph it with a smartphone. And if you start studying the constellations, you can use that to help find the Milky Way, not just by looking for Cygnus, but also by looking for Sagittarius. It also goes through Cassiopeia. Obviously, for best results, you're going to want a moonless night. And do you need a telescope? Absolutely not. And actually, you may find this really interesting. The Milky Way disappears when you look at it through a telescope. So for most of human history, there was this controversy about what is the Milky Way? Like, what is this, band of white fuzz that goes across the sky at night? And when Galileo invented his telescope and looked through it, he found out that it's just stars. That if you look at the Milky Way through a telescope, the nebulosity mostly goes away. There's a few points where there are nebulas that pop out. Like, for instance, you see this red stuff here. There's a bunch of nebulas in Cygnus. This one here is the North American Nebula. There's a bunch of others. But for the most part, the lens of the Milky Way is just stars. So when you look through a telescope, you're not really seeing much. And do you need a dark sky? Absolutely. So I'm going to talk about the moon and the planets. So the moon and the planets are a lot more light pollution friendly. They are very bright. The moon has many interesting surface features that you can explore with a small telescope or binoculars. And this may seem a little counterintuitive, but actually generally, if you really want to look at the moon, you want to avoid the full moon. you can use a telescope and look at the moon during a full moon. It will blast your eyes, so you be ready to grab a pair of sunglasses or get a filter for it. But the most interesting phases, and you can even see that a little bit in this picture, that at the half moon and like quarter phases, you'll see a little bit more contrast. You'll see a little bit more of the mountains, the craters, the valleys, the things that make the moon a real proper world. Um, and then the 6 naked eye planets. So there's 6 naked eye planets, right? So there's Mercury, Venus, Mars, Jupiter, Saturn. That's 5. 6th one is Uranus. And wait, there's one naked eye planet I forgot. Can anyone tell me what other planet you can see with a naked eye? Yes, exactly. Earth. Look, it's around you. Um, so yeah, there are 6 naked eye planets. 2 of them are what we call inferior planets, Mercury and Venus. So that means that they are closer to the sun than we are. So what's cool about Mercury and Venus is that actually when you look at them through a telescope, you can see their phases. So like the moon, they go through, a gibbous, a half, a crescent phase. But you don't really get much more out of Mercury and Venus through a telescope because they're inferior planets. That means they're closer to the sun, which means that we can only see them near sunrise and sunset. So you're always sort of looking through the haze of the atmosphere. And also, Mercury is very small. It's like about the size of the moon. And Venus is covered in clouds. So that's what's interesting there. For Mars, you'll see its polar ice caps, which I happen to pick a picture of Mars where you can't see the polar ice caps, but you can see them through a telescope. For Jupiter, you'll see its cloud bands, you'll see its moons, you'll see its that great red spot, which is a big hurricane about the size of 3 Earths. And for Saturn, of course, you'll see its rings, which is a life-changing experience that you'll never be the same after. Then for Neptune, Uranus, and Mercury, you're basically just getting a disk. So yeah, do you need a telescope to look at the moon and the planets? Probably. You don't need it to see where they are. They are naked eye objects. So obviously, I'm sure you've all seen the moon, but the planets can also be picked out with the naked eye. They look like relatively bright stars, but they're always, in one line because they're on one orbital plane. For the planets, you will need a telescope to see something interesting, but you don't need to go anywhere dark. You don't need to go to the middle of nowhere. You can see the planets. They look the exact same in New York City as they do out here or anywhere else. And I just want to make a note, obviously, this is not to scale. So I'm going to talk about solar eclipses. So we just had a really big one back in April last year here in North America. So it happens to be, by sheer happenstance, that the moon and the sun are the exact same visual size, meaning that they appear to be the same size, even though they are actually 2 different sizes. They are 400 times different, the sun is 400 times larger than the moon, but it's also 400 times farther away, so they appear to our eye to be the same size. And every once in a while, the moon passes in front of the sun, and we call that a solar eclipse. So this takes place over a very narrow band of the Earth's surface, maybe like a few miles wide, and it takes about 3 to 4 hours for the entire eclipse to occur. In any given location along that line, that is the path of totality, you will get totality, meaning the moon completely covers the sun, and you can look at the sun briefly without eye protection and see its atmosphere for about 2 to 7 minutes. Now, I want to make a note here. Do not look at the sun without eye protection. I'm going to say it again. Do not look at the sun without eye protection. Additionally, if you have a telescope and you want to look at an eclipse, you need to make sure that that telescope has the proper filters on it, not just to protect your eyes, but even if you're using a camera, you don't want to burn out the camera sensor or cause a lot of heat to build up inside the telescope. But yeah, so for solar eclipses, you don't really need to worry about dark sky. Obviously, they happen during the day. And you don't need a telescope, though they can be helpful if you know what you're doing. If you don't know what you're doing, you should not be using a telescope to look at the sun at all. We just had this big solar eclipse here in North America. I think the next one in North America is not until like the 2040s. But generally, I have been told that the best way to view a solar eclipse is like planning a heist. So you want to basically have, a bunch of different spots along the path and a car. And if it's getting cloudy where you are, you want to be able to check the weather and be like, okay, can we rush over there and see if it's clear there? I've never done it this way. I've seen 3 solar eclipses in my life, 2 of them in my adult life, and both times I just picked a spot on the path of totality and crossed my fingers and happened to be lucky. But this is how most people do it: is they kind of get ready to like, all right, I'm gonna pick up and move. So I'm going to talk about lunar eclipses. So a lunar eclipse is kind of the opposite of solar eclipse. It happens when the moon passes behind the Earth into the Earth's shadow. So lunar eclipses are a lot safer. You don't need any eye protection to look at them. In fact, actually, the moon gets darker during a lunar eclipse. And they're also a bit more democratic in that 50% of the Earth's surface can see any given lunar eclipse. So anytime there's one happening, you flip a coin. That's your chances of getting to watch it. That and your local cloud cover. So it also takes about 4 hours from start to finish, like a solar eclipse, but there's something to watch the entire time. By the way, this is also a really great way to prove that the Earth is not flat, because if the Earth were flat, then the shadow it casts on the moon would not look like a disk. There's only one shape. There's only one 3-dimensional object that can cast a disk shadow in every orientation. That is a sphere. If the Earth were flat, then the shadow that we cast on the moon during eclipses would be something other than a disk some of the time. But yeah, so what you're seeing when you watch a lunar eclipse is you're seeing basically the moon pass through all of the sunsets on Earth at the same time. And you obviously don't need a dark sky for this because you can see the moon in any old sky. And in terms of using a telescope, it definitely helps, but is not at all a requirement. And then apart from eclipses, there are also transits. So these you can look out for. There was one that happened, I guess it was in like February. It was sometime last winter, that Mars went behind the moon, and I got to watch it. I got to photograph it. This is not a photograph I took. This is a better one. But you see that little teeny tiny dot right there is the planet Mars going behind the moon. So you definitely need a telescope to enjoy watching a transit. You're not going to be able to see anything that's all that interesting with the naked eye. And they can be less common. You want to sort of look out for them in the astronomical news. Usually you'll see things where it's a superior planet passing behind the moon. Our inferior planets also sometimes pass in front of the sun. Venus is going to pass in front of the sun in, I think, 2112. So I'll be waiting out for that one. I think Mercury is going to do a transit more soon than that. I think it's in the 2030s. And then another thing that you can look out for is outer planet moons will often cast a shadow on their planet. This is called a shadow transit. So when Titan goes in front of Saturn, or when Europa goes in front of Jupiter, you can see that through a telescope. And again, this is another thing you don't need a dark sky to enjoy. Ooh. Okay, so now we're going to talk about... Was that a dog? Okay. So now we're going to talk about what is basically the meat and potatoes of amateur astronomy, deep sky objects, which basically means objects that are outside of our solar system, usually composed of many stars, clouds of gas and dust, or structures of stars like galaxies. So these are all pictures I took, actually. These ones I actually did myself. And I think I know the Andromeda Galaxy one I took here. The Bubble Nebula, that might be from Stellophane. I'm not sure. But so these are kind of the 3 broad categories. You have galaxies like Andromeda, you have nebulas like the Bubble, and you have star clusters like M52. You're not gonna see anything that looks exactly like this through a telescope because your eyes are not really well adapted for detecting color at low light. So when you look at something like the Bubble Nebula through a telescope, you will see basically the same thing, but you're not going to see the red color. Um, and the amount of detail is obviously enhanced by the fact that it's a long exposure photograph. So if you want to see things like this, you've obviously come to the right place. We have a bunch of telescopes that can show you these kinds of objects. Unfortunately, they don't work through clouds. The best way to see these sorts of objects is to attend a star party in a dark area. You can visit your local observatory, for instance, this one, or you could get your own telescope and book a campground. So, do you need a telescope to see these? Basically, yes. There's a few really big nebulas and big galaxies that are readily, easily visible in binoculars. And if you know where to look, there's a few things that you can actually see with the naked eye. But in my experience, I think that the people who know where to look usually have looked through a telescope at these objects. You need a dark sky to see basically almost all the galaxies, like except for Andromeda. You can see Andromeda in a pretty light polluted sky, but it's obviously less interesting. And the star clusters are usually pretty easy in a light polluted sky, but most nebulas you're going to want it to be pretty dark. So then comets, I would say, are actually my favorite ephemeral astronomy event. I like comets better than eclipses and better than transits because seeing a comet is really nothing like planning a heist. So comets are basically flying mountains that orbit the sun on very long elliptical paths. These can be orbits between 100 years, 200 years, out to maybe tens of thousands of years. So this is a picture I took from here, Jenny Jump. This is Pons Brooks, which is a Halley-type comet. So it's on like a 92-year orbit, I think, something like 92 to 96 years. So you stick around, it'll be back. So as comets approach the sun, the heat from the sun causes the ices inside the structure of the comet to sublimate. So sublimation is when we change from a solid to a gas directly without passing through the liquid state. So, and that sublimated gas forms the tail of the comet. The tail of the comet will always point away from the sun. So as it's falling toward the sun, it kind of looks like a rocket where the tail looks like it's going back behind it, and then as it goes around and away from the sun, it's blasting. It looks like it's going backwards. So comets can be seen with binoculars, telescopes, and even the naked eye, depending on how big the comet is and how close it is to Earth. And generally, what you're gonna see, like what the way you're gonna see a comet is, you want to look out for one. Has anybody seen Comet Lemon, by the way? That one's coming through the solar system right now. Anybody? All right. So if it weren't so cloudy, I would have suggested we take a look and try to see if we can see Comet Lemon tonight. It's going to be in the southern sky, I think. But basically, you're usually going to find them near the plane of the ecliptic. And they usually, there's not a hard and fast rule for this, but they often kind of are in the same vein of like the planets where, or the inferior planets where you want to look for them near to sunset in the west or in the eastern sky, because that's when they're getting close to the sun. They're getting pretty bright. They can, a comet tail will go for millions of kilometers into space, so they can be big enough that you can't fit them in the telescope. But usually they're gonna fit in a small telescope. In terms of dark sky necessity, it varies depending on the brightness of the comet, but usually you're gonna want it. And I'm gonna talk about meteor showers. So this is one of the things that gets really hyped up all the time. So there are these things called meteoroids. And this, you gotta keep your head screwed on straight to understand this. So there are these things called meteoroids. These are these bits of rock, basically grains of sand, that are orbiting the sun or passing through space. And as they enter the Earth's upper atmosphere, they burn up, and they cause a fireball, which we call a meteor. Okay? Now, if any of the pieces of the meteoroid that cause the meteor land on the ground and are recoverable, then we call that a meteorite. There's going to be a quiz on this. Okay, so now it happens to be like meteors can occur at any old time. That you could see one tonight. You might even see one through the clouds. That happens. But when the Earth passes through the orbit of a comet, we experience a burst of meteor sightings that we call a meteor shower. There's a bunch of famous ones like the Perseids, the Orionids, the Geminids. They are generally named after the constellation that we call the radiant. So this is basically it's the direction that the meteors all appear to be coming from. So like if you're looking for the Perseid meteors, what you want to look for is you want to look at the constellation Perseus and like away from it. You want to see things that like it's going to look like it's coming out of Perseus and going across the sky. And because we know the orbits of regular comets, we generally know when meteor showers are going to happen. I'm pretty sure that most of it's like 2/3 of the named meteor showers are associated with we know what comet they came from. There's a few of them that it's like, well, we know this meteor shower happens. We still haven't identified the comet. It might not have been back in the inner solar system during the period where we had astronomy. So for meteor showers, do you want a telescope? Absolutely not. It would likely be a hindrance. There is no way you can see, like you might see a meteor in the telescope, but you're not going to see it for very long because meteors are going across a huge swath of the sky. But you would probably want a dark sky, and the darker the better. Basically, the best way to experience a meteor shower is in a lawn chair with a hot cocoa, relaxing with your friends. Now I'm going to talk about satellites and the International Space Station. So you can basically see satellites on any clear night from anywhere. There's actually a lot of these things now. We'll talk a little bit more about that. But you tend to spot satellites around sunset or sunrise, and this is because this is the period where the sun is reflecting off of their solar panels, because they're way up there, right? So like they can see over the horizon toward the setting sun, so they're getting a bit of sunlight that we're not. And basically, what you want to look for to see a satellite is you want to look for something that looks like an airplane, but it's not blinking. There's no anti-collision lights on it. The two of the brightest satellites are the International Space Station and the Chinese space station Tiangong. So this is a picture I took. I was taking a time lapse of the Milky Way from Stellafane. This was 2 years ago, and I actually I went. So Stellafane is an astronomy convention. It's a camping astronomy convention. So usually, I'm having a night at Stellafane. I might set up my gear, taking pictures, and then I go to look at all the other telescopes and look at what people are looking at. And I happen to come back to check on my camera just to see that nobody messed with it. And I hear people scream, "It's the ISS!" And I have this app on my phone that tracks when I'm going to see the ISS. And I look at the app and I'm like, oh yeah, it's the ISS. And then when I got home, I got the picture out and found the frames that had this object, which is right here. And it turned out indeed it was not the ISS; it was the Chinese station. But yeah, so this is another one where your best viewing is really naked eye. I have tried to look at them through a telescope. Sometimes you gotta get two guys with a red, a reflex finder, and you just sweep really fast. And you might manage to get it in the eyepiece. I'm pretty sure I saw the ISS's solar panels one time by doing that. But generally, you want to do this with the naked eye, and you don't need a dark sky, especially not for things like the ISS. They are super duper bright. And you can get some apps that will show you when they're going to come over your head. So this is a special kind of satellite thing. This is a Starlink satellite train. So if you're not familiar with Starlink, so Starlink is a satellite internet service offered by SpaceX. And when they launch them, basically what they do is they stack a bunch of these satellites in one Falcon rocket, and they launch it into a parking orbit. and then each one of those satellites separates from the Falcon and has its own ion thruster to boost it into its final orbit. So for a little while, for like a couple of weeks after a Starlink launch, you'll see this like train of satellites going across the sky together. They look really weird, and because of like the twinkling effect of the atmosphere, sometimes it kind of looks like they're sort of like wibbling across the sky, like one of those caterpillars from the Mario games. Um, so anyway, yeah, this produces a lot of UFO reports. They look cool. And also, one time I was actually doing a talk here, and one came right over us, like right over our heads, and everybody rushed out to look. It was really cool. But anyway, if you're curious about whether this is a good idea to be launching this many satellites into low Earth orbit, you should Google Kessler syndrome. Or you should watch the movie Gravity with Sandra Bullock. That movie is about what's going to happen because of all these. Okay, so I don't think this is going to work. It's not going to work. That's okay. I already loaded it up. So this is a time lapse of the aurora from about a year. It's about a year ago. We had this night here. So you can see this is like right behind you over there by the sign. So the aurora borealis is caused by charged particles from the sun that interact with Earth's magnetic field and Earth's atmosphere as they are drawn toward the North and South Pole, or the North Pole. The aurora borealis is the northern lights. The aurora australis is the southern lights, because australis just means southern. Unfortunately, the aurora is not terribly predictable. You can look out for forecasts from NASA for what space weather is currently like, but those are often not reliable. Further north is better. During extreme solar storms, we can see auroras from as far south as about 20 degrees north latitude, which would put us in North America. That puts us in Mexico City. We here in New York area are at about 40 degrees north latitude. And the green you see in the aurora is actually oxygen at about 100 kilometers altitude. The red is oxygen at about 200 to 300 kilometers. And all the other colors are likely caused by nitrogen at various altitudes. So, again, do you need a telescope for this? No, this is another one where a telescope is kind of a hindrance. This is kind of another, like a meteor shower, this is something that you want to look at on a lawn chair. I actually, that night that I just showed you that time lapse of, there was a couple of guys here who were trying to do astrophotography, and they were like, oh, I can't do this because there's an aurora in the way. And this is another one where a dark sky can probably help. Sometimes if you can't see it with the naked eye, you can take a camera and do a long exposure pointing north, and you might pick up some aurora. But I've had nights where I thought I was picking up aurora, and it was probably just light pollution. What is going on? There it goes. Yes, this is the next thing. Okay, so finally, just a few resources. So I've given you a lot of like basics of sort of what you want to do, what the kinds of things you can check out are. Now just a bit about how to actually experience it. So every month we do a What's Up talk here at UACNJ, so you can see sort of a preview of what interesting things are in the sky. If talks aren't your thing, you're looking for something a little bit quicker, I recommend the monthly podcast, Sky Tour podcast from Sky and Telescope magazine. It's like a 10-minute podcast, drops in the first of the month. It gives you a lot of that same kind of information. To look up for future eclipses and transits, timeanddate.com is good. For satellites, you can use heavensabove.com, which has a dash in the middle. You probably want an ISS detector app. I recommend if you download an ISS detector app and it gives you a notification that the ISS is about to go over, you should open the app and make sure that it updated your location, because I've had a few times where I flew to another country and then it was like, oh, the ISS is coming over, and I'm like, hey, everybody, come on, let's go out on the balcony and see it. And there's nothing to see because it was still in New Jersey. Uh, for general stargazing stuff, I recommend Stellarium. Sky Safari is also good. There's other apps you can get, but so Stellarium is nice because it has a mobile app that will automatically adjust to your local time and date, your local time and location, and it will try to use your phone's compass and accelerometer to like match which way you're pointing in the sky. I can't speak for a lot of the other ones, but that's generally what you're gonna get in a smartphone or mobile app. I can't stress enough how cool it is to join your local astronomy club. You'll meet cool people and find cool stuff to do. But I think the most important thing here is to talk about how to beat the light pollution. So there's this cool website called lightpollutionmap.info, and you can use it to scout out dark areas near you to experience these space events. I have some bad news for you. In our society, it is generally not the case that you're supposed to be places at night. A lot of public places that you're allowed to be during the day, either you're not allowed to be at night, like a state park, or if you are there at night, people start wondering what's going on. So one resource that's great for that is a club like this one, where we have an arrangement where we're allowed to be out in the state park at night.
Special dispensation. I can't talk.
Exactly. But another option is to go camping. I love going camping with my telescope. If camping's not your thing, and even being a part of a local astronomy club can give you some alternatives. So, for instance, my club, Amateur Astronomers Association of New York, we have a relationship with the state of New York that allows us to use North-South Lake Campground. So I'll go up to the campground and go camping, bring my telescope. But if you just want to go up and hang out with the club and drive home in the middle of the night, they just use a parking lot that has a nice clear sky. It's a relatively dark area. There's others that you can find from our website. For instance, I think it's Rockland Astronomy Club has a place called Starhaven that they run up in upstate New York. And also you can come here as long as we're open. All right. That's it.
I thought there was more. I was waiting. I'm like,
Yeah, there's
all
you.
right, what? All right. Thank you, Den, for another great talk. So we are going to be doing a question and answer session. But before we get into that, I do want to point out on my table there is candy, and there is also a small dish with non-candy treats such as stickers and small ducks. They are not edible. Please do not eat the small ducks. They're the plastic. Please don't eat them. But I know some people can't have candy, so I'm like, small alien duck. Why not? Do feel free to take some. Please leave my containers. I have a pot roast to make in that cast iron pot later this week, and the cast iron pot actually does help with that. That being said, I think a couple of you snuck in while the presentation was going, and therefore thought you were going to escape the safety briefing. But alas, it is unescapable. If you guys need to use the restroom, like I said, porta potty in back, it is big, it is blue, it is illuminated by red for ease of finding in the dark. We also have a little museum and gift shop area available. Feel free to check that out. Like I said, all proceeds go to helping us pay the bills and keep offering the free public programs. Speaking of that, I do want to thank everyone who has helped us out this season. Your donations are greatly appreciated just because it does allow us to reach more people and do more outreach. Each of those sheds you saw coming in does have a telescope. I think the large alien that was distributing treats to you just a little bit ago has his open adjacent where the roof is not rolled off because the sky is still cloudy.
You gotta trick the sky into clear. You can't open the telescope; it's just gonna stay cloudy.
Yeah.
You gotta make the sky gods think that you're closing up.
But he can at least show you the type of setup we have going on. I don't know that I actually have another telescope open. I'm sure someone will come running down and tell me later, hopefully. That being said, when we go to leave, anyone who drove in, please use your headlights. I do know we had a number of people hike in. We do not want to run the people who hiked in over. Use your headlights. People, be aware that there are going to be moving vehicles, and get out of the way of the moving vehicles. We do not want to play Frogger. It never ends well. That being said, any flashlights we may use to wander around, try and keep those lights pointed towards the ground so we don't accidentally blind people, because that is just no fun. With that being said, how question and answer session is going to work for the people here. You're going to raise your hand and kind of wave it about like you just don't care, because I am like the Jurassic Park T-Rex. My vision at night is based on movement, since I've been staring at a screen and I have no night vision. Online people, you have it easy. You're the reason I have no night vision. Just type it in on your internet-enabled device, and I will see it on my wrist. So I'm going to start this off with our first online question, and is, what is your bucket list thing still to do with astronomy?
Oh, that's easy. I want to go to the southern hemisphere, either Chile or Australia or any other country in the southern hemisphere where I can see the Magellanic Clouds. So here in the northern hemisphere, there's arguably two naked eye galaxies, Andromeda and Triangulum, but the Magellanic Clouds are actually satellite galaxies of the Milky Way, and they're visible from the southern hemisphere. They're really big. Like they make Andromeda look like a second-rate attraction.
The difference between jumbo prawns and popcorn shrimp, I'm told. If you're, which is unfortunate for me since I'm allergic to shellfish. All right, any questions out here? I think I saw one all the way in back that raised their hand first. Just give me a moment to get out there so I don't... You put your hand down. You're lost. There we go. I wasn't joking about being the T-Rex.
I just wanted to ask, you mentioned like a club. Like what was the name of it, and like how would you join that?
Well, I mentioned a few clubs. The club that operates this observatory is called United Astronomy Clubs of New Jersey, and in order to join this club, you have to join another club. So the club that I'm part of is called Amateur Astronomers Association of New York. Our website is aaa.org. We're the original AAA before the ones with the cars. And to join the club, all you got to do is pay your annual dues. And
also, our website, great source. It has a list of all our member clubs, and we have some literature from some of our member clubs in the little museum and gift shop area. So, right, I saw another one. Hand.
Hi. If you post astrophotography, I actually do want to know your Instagram.
Oh yeah, it's I'm at the Intergalactic Wanderer, which is a real mouthful, but it's actually a real object.
Ooh, and we have two down here. Oh, sorry, I didn't mean to stomp on you.
What's your favorite planet that you've seen?
I'm gonna say Arrakis. But I saw it in the movie Dune.
I'm like, that's not a real planet.
It's really, I saw it in the movie. A real planet. And I have to have seen it. Do I have to have seen it with my eyes?
Yes.
Okay, then probably.
Well, you're not gonna see it with your ears, dude.
Well, as opposed to seeing a photograph. I'm gonna go with Earth. Close second, Saturn. Third place, Arrakis.
All right. So our next online question: are there ways to collect your own meteorites? Like they saw a meteorite and now they got it.
Sure. I mean, you'd have to find the meteorite first. I have no idea how you would find one after it. I'm pretty sure that most of the time when a meteorite is recovered, it's not because somebody saw the meteor and then found where it landed. I think it's usually that they found a weird rock and then they chemically analyzed it and said this had to come from space.
Right, and we got another question out here.
What's your favorite nebula? And since your planet question answer, I've got to say real. Your favorite real nebula.
Non-fiction nebulas.
I was gonna, I could have named a fictional nebula. I think probably. So I mean, the North American nebula is pretty near and dear to my heart because it was like the first. It was the first object that I photographed that got me into astrophotography. But I think the Orion Nebula is more beautiful. Like the Orion Nebula is so cool. Like it looks beautiful in any, in any magnification, in any light pollution level. You can see it almost like you can see it naked eye in New York City. It's so bright. So yeah, I'm going with Orion Nebula.
Right, we got another one.
How can you see the Milky Way if it were part of the Milky Way? Like when you showed us that picture, like how could we see it if we're part of the Milky Way?
Because what we see as the Milky Way is we're looking out at the disk of the Milky Way. So like it's like imagine the Milky Way is like a plate, right? So like if you were sitting on a pie plate, you would look around and you would see like out to the edge of the pie plate. That's why we can see it.
Right, we got another one.
Can Milky Ways be different shapes?
I think you mean can galaxies be different shapes? Because there's only one Milky Way. And yes, or unless you meant the candy bar, in which case if they're a different shape, that's a manufacturing defect. So yes, galaxies can be different shapes. Our particular shape of galaxy is a fairly common one called the barred spiral. The Andromeda, which I showed you before, is also a spiral galaxy. So that's like the regular form. You often find irregular galaxies that are just like weird little like blobs of stars.
Space amoebas.
Yeah. But the big ones are usually spirals.
Okay, I'm like, I saw the phone and then it disappeared. Right.
By the way, if you want to see the North American Nebula, go on my Instagram.
Name some other galaxies.
Well, all right, you got Andromeda, right? So I already mentioned that one. I already mentioned the Magellanic Clouds. They're both technically galaxies, though they are satellite galaxies. Triangulum, that's the third one in our local group. Then the next, like, big galaxies, like, there's a bunch of little tiny galaxies in the local group, like the Magellanic Clouds. They're, like, satellites of Andromeda or satellites of the Milky Way. But, like, the next big group of galaxies, which is, like, 30 million light years away, is the M81 group. M81 has a neighbor galaxy called M82. These are also commonly called Bode's Galaxy and the Cigar Galaxy. I could go on, but I mean, I think you get the picture. I know a lot of galaxies.
Right, we got.
So, why can you not look at this? Like when there's a solar eclipse happening, then why can you not look at the sun without eye protection?
Because it will hurt your eyes. No, in all seriousness, so during a solar eclipse, you should not be looking at the sun without eye protection. For the same reason, you should never be looking directly at the sun without eye protection. It will damage your eyes. During totality, you can look at the sun without eye protection, but you have to be very careful because as the moon passes beyond the sun, those first few rays of light that come from the sun could damage your eyes. So I would recommend not doing that or being super duper careful.
So to also expand on that, what it does is damages the light receiving structures in your eyes. And if you get too much damage, you will go blind. And if you look, there's every time an area has a solar eclipse, there is an increase in eye injury problems, and why we also want to use proper filters on our telescopes, binoculars, or anything, or if you're using a camera, because it will damage your eyes or sensor, because you will be treating whatever's behind that lens like an ant under a magnifying glass.
Mm.
You basically burn it, quite literally.
You should definitely not look at the sun with your remaining eye.
As Paul Fisher would know.
What's your opinion on the Hercules Corona Borealis Great Wall?
I should have known this one was coming.
What the hell is the Hercules Corona Borealis Great Wall? Am I too
Okay.
old to get this meme?
No, this is actually apparently a thing.
So it's a thing. So basically, it's the largest known structure of galaxies in our known universe. It's 13 billion light years long, 7 billion light years wide, and 13 billion light years away from Earth. And we actually don't know how long it is because it's so far away we can't see the end of it. But it's like one of the borders of our known universe.
Okay, yeah,
Google it.
my opinion is it's super rad.
She needed to stop giggling first.
Do you know what the horse nebula thingy is called?
The horsehead.
The Horsehead Nebula.
Horsehead
Yeah,
nebula.
yeah. That's my my background of my computer. I took. So this is a photograph I took of. So this is Orion. This is the
Did you
Orion
hold your hand
Nebula up here, and this is the Horsehead Nebula down here. This is Orion's belt. This star right here is called Alnitek. This is the leftmost star in Orion's belt, and it's right next to these two nebulas, the Flame Nebula and the Horsehead. And it's like this is one of the hardest objects to visually see because you have this stupid bright star in the way that keeps messing up your night vision, right? But it's really easy to photograph because you just get this star in there, and the camera sensor does the rest.
Right, and we had one over here.
So that kind of leads me to this question because I went to New York and saw the Aurora Borealis, and we saw it, but it wasn't as vibrant. When we took pictures, the pictures on our phone made it look really vibrant.
Yeah.
So I was wondering, and you just kind of said that the if there were other tricks in the sky, that if you photographed, it was a whole different looking color or image.
So the main reason for this, there's two reasons for this. One is that camera sensor is actually just more sensitive than your eye. Another reason is that the camera, your eye is taking if you want to analogize it to a camera, it is taking a very short exposure. Whereas with a DSLR camera or any sort of camera, you can take an arbitrarily long exposure, basically leave the shutter open for longer than your eye is leaving the shutter open, and then get more photons, get more detail. Then the next stage of this is with the photographs I've shown you that I've taken, I'm not just taking advantage of those raw aspects of how camera sensors work. I'm also stacking the photos to remove signal noise. I'm taking calibration frames. I'm doing a bunch of tricks in post-production to get more of the details out than the camera, than a single exposure can take. So that's why astrophotos always look better than what you see with the naked eye. Even just a long exposure photograph is going to look better than what you see with the naked eye.
Oh, because someone messaged me to remind me. I know treats are passed out. There is candy available. I do ask that we be mindful, keep our trash on us. It is a state park. It is carry in, carry out, so that we keep the site looking nice and don't leave trash. Okay, guys? Right. I saw one here. Do you need me to wait and come back?
Yes. So is that how does what color is the moon when a lunar eclipse happens?
So it's gonna start out looking red, and it's looking red because of it's reflecting the sunsets from the Earth. It's reflecting the Earth's partial shadow, also called the penumbra, and then it'll get darker and darker, and eventually become like sort of almost black as it passes through the shadow of the Earth completely, and then it goes red again, and then it goes back to the normal color of the moon, which I'm not sure I think I would say that the
Gray?
moon is silver. Is it silver? Is it gray? Is it white? I've heard that actually if you take moon dust, like the average sort of like rocks on the surface of the moon, and you put them down, on the table, they look like chalkboard color. They're like almost black. But the reason why the moon appears to be like silver is because it's bathed in direct sunlight.
Alright.
How much feet is the Milky Way?
How much feet? Well, okay, so it's 100,000 light years, and a light year is 60,000 astronomical units, and an astronomical unit is 150 million kilometers, and a kilometer is so a mile is 5,000 feet, and a kilometer is like 2/3 of a mile. So it's like 2/3 of 5,000 times 150 million times 60,000 times 100,000. Can you do that math? It's simple
All I
arithmetic.
heard was that no.
Every one of us can do this on our phones.
Yeah, that's a lot of math. I suggest.
And that's diameter, by the way. That's diameter. Like I'm not sure how else you would measure, like linearly measure a 3-dimensional object.
All right.
For that photo that's your computer home screen that you showed us before, how long did you have to have the exposure out to take that?
It was a long time ago that I took that photo. If you look at my Instagram, I definitely included I included all my photos the technical details of like exposure time, camera, whatever, like location, all that stuff. But I think I took that from Hoboken. I don't think I didn't need to take it to go to a dark location for it. And I think so since I was shooting from Hoboken, I probably used shorter exposures, like maybe 30 seconds, but I stacked a bunch of them. It was probably like 3 or 4 hours. So like usually you want to shoot it depends on the object. Some things are brighter and it's not worth bothering collecting more data, but it's really more like the total shooting time. So like the trade-off between like I like to do 5-minute exposures because it makes the math easy. It's 12 per hour. Some people do 6 minutes because it is 10 per hour. But I mean, fundamentally, it doesn't really matter how long the exposure is than how long the total is. And if you're shooting in a light polluted area, you want to go to shorter exposures. It does mean you collect more data because like each individual exposure is like 50 megabytes. Right? So like if you're doing 30-second exposures versus 300-second exposures, your hard drive fills up 10 times faster.
Balancing act. Online people, I do ask if you have any questions, do get those in, and I like to tell them ahead of time because by the time they hear this message, we're already 2 minutes into the future since that's how stream delay works. The next online question was, could military missile tracking telescopes track a meteor?
Probably. It seems likely. They're basically designed to do exactly that, right? They're designed to track small objects falling from orbit.
Going really fast.
So, like, Andromeda Galaxy and the Milky Way are going to crash, right? But how would that happen?
Oh, well, so, I mean, in terms of, like, mechanically, what's likely to happen. We don't know with 100% certainty this is going to happen, but what it seems likely will happen is that the two galaxies will fall into one another, and as they merge, basically, because there's so much distance between the stars, what's going to happen is the stars are not really going to hit one another. They're kind of going to, like, pass through, And what you'll see is like if you watch like animations of the simulations of what the Andromeda Milky Way merger will look like, is you'll see like the Andromeda stars will kind of pass through, and then they slow down and they like fall back in, and they sort of get all churned up until eventually it becomes this one big giant galaxy, Milkdromeda. If you think about it, it's kind of like if you were like swinging on a swing, right? So like if I'm pushing you on a swing, at the point when you are like closest to the ground, you're going the fastest. And then you pass by that like that point, and then you slow down, and you fall back in. This is basically what's happening. Is it's like Andromeda is the person on the swing, and the Milky Way is the ground. It's like, oh, I'm being pulled in, but now I'm going really, really fast, so I overshoot, and then I come back a little bit, and then eventually it all settles out. Does that make sense?
Yeah, so lots of empty space in galaxies. So it's kind of, I don't know if you've ever seen YouTube clips of where they have the formation walking competitions where they're like like the marching band thing where they're and you're like they're gonna collide and then they just miss each other.
It's nothing like that.
It's like with more gravity and physics involved.
Yeah. Also, by the way, this has already happened several times. Like, the Milky Way has consumed several other galaxies, and basically, it appears that this is kind of what the cosmos is always doing. The galaxies are just getting glommed together bit by bit into bigger and bigger structures.
All right, next.
So I remember from like the intro, you said that you were a childhood amateur astronomer. Like
That's
you've been doing this
true.
since childhood. What got you into it, and how old were you when you realized you liked it?
I honestly have no idea. Like, I was 12, but I know my dad was interested in it. I remember my dad told me my dad grew up in England, and he told me that he grew up watching Patrick Moore on television. He was really famous in England, and he had a TV show called Sky at Night, which ran. I think it ran until he passed away. He passed away like 10 years ago. But so I think my dad was kind of interested in it, and maybe I expressed some interest, and then he got us involved in our local astronomy club. And then, like, when I was a kid, like, we would go to star parties, and I would come back to school, and I'd be like, oh, hey, we went camping this weekend. And my classmates would be like, whoa, where'd you go? And I'd be like, oh, we went to this big field with a bunch of people with telescopes. And they'd be like, Daniel, that's not what camping is.
It is. Just
Yeah, it's
differently. All right.
Do you know what the cat's eye is?
I believe there's a nebula called the Cat's Eye.
I think so.
Is it your favorite nebula?
All right. Any other last
Thor's helmet. Thor's
questions?
helmet's also good. Yeah, it's a cool one.
I think there's an image of Thor's helmet that's going to be in the 2026 calendar. We finally, hopefully they're in the mail. Hopefully. So, unfortunately, it doesn't help me now, but you know, we'll have them at the start of next year, definitely. Any other questions? Bueller? I hear the crickets. I got asked, is the sky clear? No, the sky is still very cloud.
How many feet wide is the planet Earth?
Okay, so the planet Earth. So Earth is about 12,000 kilometers in diameter. So is that right? That sounds right. Yeah, it's 12,000 kilometers, 40. So the meter was defined originally to be 40 million meters circumference of the Earth, and now we define the meter differently. But so the Earth is 12,000 kilometers, which is 12 million meters. A meter is about 38 inches, so like 3 feet and change. So that makes 12 million times 3 and a little bit extra. It's a little bit less than 40 million feet.
That's a lot of feet.
Yeah, that's a scrutable number though, right? Like you can imagine a million.
Am I seeing a hand up over there, or are you scratching your head? Okay. Uh, like I said, my vision's entirely based on motion, so when people go completely still.
How old is the Milky Way, and how did it start?
I'm pretty sure that the Milky Way is about as old as the universe, right? Like that sounds right. Which would put it at like about 14 billion years old. The Milky Way started because of basically the reason why we have galaxies where we do is because they were like areas of relatively high density in the early universe. So like because gravity like pulls more stuff in, as like you have a dense if you have a dense region, you'll have more and more stuff get pulled into that region, and it eventually agglomerates to a big galaxy like the one we live in.
Right. So I'm gonna take one more question out here, and Dan's probably gonna be around for a little bit, so you can ask him all the fun questions. See if you can stump him. That's his favorite.
I feel like a few of them already got me.
But it's fun, and it's his favorite pastime to do to other presenters. So we might as well return the favor. But so I said one last question. I saw your hand up, I believe.
Yes, I was just curious about, you mentioned the movie Gravity and the Kessler Effect, and how serious are you about that?
Oh, I'm dead serious. I think that so the movie is fiction. The movie is not a likely version of the Kessler scenario. But at this point, so for those, I was alluding to this because I want to build awareness about it, but it's kind of out of scope for the talk. But I will explain. So there was this scientist named Kessler who in the early 70s predicted this problem where it's like if we launch too much stuff into low Earth orbit, then eventually what can happen is as those objects like there's junk, there's literal trash, there's bits of like bolts and things that fell off, and if you have a collision between two things in like a perpendicular orbit, then that relative velocity is basically like a rifle bullet. In fact, actually, it's like 7 or 8 times the velocity of a rifle bullet. So what you're gonna have is you're gonna have shrapnel. And when you have shrapnel, that causes more collisions, and it is a possibility that we will not be able to access space because we're basically launching through a cloud of shrapnel. Now, in the movie Gravity, this happens because I think it's like a Russian satellite that the Russians shoot down, and then it like causes this cascading wave of debris. At this point, within the space science community, the consensus is this is happening. There's disagreement about how fast this is happening and how dire the situation is, but I would compare it to like climate change in the 90s, where it's like we all agree that this is going on. The only disagreement is like how urgent the situation is. And yeah, like I think there's a strong likelihood that we will find that we might not be able to access outer space in the future because there's too much shrapnel in the way. Now, the Starlink happens to be actually not the worst offender, in part because their satellites are designed to burn up in the atmosphere within 5 years. They're basically disposable, so they're in such a low orbit that they're not that big of a problem. It's the things that are in the middling orbits that are causing the real concern.
We had a presenter earlier in the season, Dr. Chirag Scholar, give a talk on space trash, and he went into some of those concerns and the math behind them. So if you were interested in more information on that, I do suggest we have it saved on our YouTube channel. In the past, you can either go to our website and click the link next to that talk, or like I said, you can go to our YouTube channel, and right now it's saved under live because that's where YouTube saves live broadcasts instead of in past broadcasts, and I don't know how to fix that. Yay. I don't know why that was a yay, but I do want to thank everyone for coming out here and joining us online. I do want to thank you, Dan, for another great talk. Happy Halloween. Like I said, do feel free to grab some candy. We have some non-candy treats on my table as well. Do not eat the non-candy treats. I only say this because I handed one of the alien ducks to one of my volunteers once and they popped it in their mouth. Let's not do that, people. Not candy.
Good night, everybody.
With that, have a good night. Clearer skies than we have, and good seeing.